All right, so this is rational functions graphs part 2. If you need the first part of the lesson, please go and look back at that first video. In that first video, we also talked about the parent function, which we did in part 1, and we went over example 1 of graph f of x plus 2 divided by x squared minus x minus 6. And we talked about these removable discontinuities that are in the graph, just one, and then also the asymptote. Now let's go ahead and take a look at example 2. So with example 2, we're going to kind of talk about the steps that we're going to perform before we get into locating the vertical asymptotes, the holes, the x-intercepts, the y-intercepts, those kinds of things. We're going to be able to calculate most of those using algebra. So the steps that we're going to start off with first is we're going to first factor the function. So that's the first step. So in the numerator, I notice that I have a difference of squares, so that could be factored out as x minus 1 and x plus 1. If you factor those two out, you would still end up with x squared minus 1, because remember the two numbers, or the two signs, would end up canceling the middle term out, and you would just end up with x squared minus 1. So that's the first step, is to go ahead and factor the numerator and the denominator. Now in the denominator, I notice I have a middle term. So I need to think of my factors of -3. That'll add up to give me +2, and that's going to be 3 and -1. So it's x plus 3 and x minus 1. Now the next step is I'm going to go ahead and simplify the function. So simplifying the function just means that I need to look to see if there is anything in common, and there is. So the x minus 1 is the same in both the numerator and the denominator, so that's a removable discontinuity that I can go ahead and kind of state over here. X minus 1 is going to be a removable discontinuity, set that equal to 0. And x I know cannot equal +1 if I add that 1 over to the other side. So I'm going to have a hole at when x is 1, what would the y value be? I'd have to plug it into my formula, or as far as my simplified equation, and I could figure out where that hole is going to be. So it's going to be x plus 1. So I can go ahead and write that down here. So the x value is 1 plus 1, 1 minus 3, which would just simplify to -1/3. Whoops. And that would be my y value. So at that point, I would have a hole in the graph. Let's go ahead and talk about other things. We can see that the asymptotes, vertical and horizontal, my vertical asymptote is whenever we set the denominator equal to 0. And that's another discontinuity. So I'm going to set my denominator, which is just going to be x minus 3 equals 0. I'm going to add the 3 to the other side. That would just be x equals 3. And that's where I cannot have value because it will end up being a vertical asymptote. Now for the horizontal asymptote, I'm actually going to look at the leading coefficient, or the degrees of the x value, and when I look at that, we're going to end up having 1. So our horizontal asymptote is just going to end up being x equals 1. And I'm going to explain more about that. Now, when we factor, oops, I didn't do that. I should have done that here. X minus 1, x plus 1, all divided by x plus 3 times x minus 1. These simplify out, which leaves us with f of x equals x plus 1 divided by x minus 3. Alright, so we can kind of fill in a little bit into our graph as to what we're doing so far. Because we talked about vertical asymptote being at 3. And then our horizontal asymptote being at +1. Next, we can talk about our whole at negative 1.3. So that's down here. Okay. The next thing that we can look at is the x-intercept. If it's an x-intercept, we know that y is going to be 0, so we can substitute the entire equation, which is just going to be x plus 1 divided by x minus 3 equals y, or f of x normally, but since we already know that the y value is going to be 0, it's 0. Okay, I'm going to show this the first time, but really your y-intercept or your x-intercept is only going to be stating the numerator equal to 0, and the reason being is the next step to solve for x is to multiply both sides by x minus 3. X minus 3 times 0 is going to cancel out, so we're going to be left with x plus 1 equals 0 and x equals positive 1. Okay, so we're going to have a x-intercept at positive 1, 0. Nope, sorry, negative 1. Just noticed I had a mistake there when I went to go graph that. So at negative 1, whoops, come back. Hold on, guys. There we go. My hand hit the bottom. I apologize. So x equals negative 1. So we're going to have an x-intercept at negative 1, 0. So that's going to be another piece of information for our graph. Our y-intercept, whenever we have a y-intercept, we know that the x value is going to be 0. So we're going to substitute it into our simplified function, which is going to be x plus 1 divided by x plus 3 equals the f of x, or y. And so we'd have 0 plus 1 and 0 plus 3. Our y value is just going to be 1/3 equals y. So our ordered pair is 0, 1/3. Okay. Looking at the domain of our graph, we're going to go ahead and sketch this. It's going to start off in this quadrant. And in this side, we have 0, 1/3. We have a hole at negative 1, 0. And 1, negative 3. So it's going to go through here, come down, keep going. Okay, and so if we talk about our domain, it's going to be all x values. So if we are doing that in all x values except for when x cannot equal positive 1, or in this case, positive 3. So if we're doing that in an inequality, this is going to be a little confusing, but we're going to start off by negative infinity. Less than x, less than our first value, which is 1, union 1, less than x, everything between 1 and 3, union, and then everything between 3 and infinity. Positive infinity. Kind of crazy. Totally get it. Now the next one is going to be an interval notation, so that's when we're using parentheses or brackets. So we're going to start off with negative infinity, parenthesis, okay, all the way to 1, parenthesis, 1 to 3, but we cannot include 1 or 3. That's why they're in parentheses. If we could, then it would be a bracket all the way to positive infinity. And then its set builder notation is going to start it off with all the x values such that negative infinity. So everything you have here for the interval notation is what's going to go, or inequality notation is going to go inside the set builder notation. So less than x, less than 1, union 1, less than x, less than 3, union 3, less than x, less than positive infinity. Okay, close brackets. All right, so the range, we're just going to go ahead and state using, so these would be the y values. And that would be all real numbers except y cannot equal, in this case it's our horizontal asymptote, which shifts up, I'm sorry, not shifts up 3, but that would just be that y cannot equal 1, so it's never going to cross for 1. Okay, so let's go ahead and take a look. You can go ahead and fill out the rest for inequality, interval, and set builder notation based off of what we did for the domain. Let's go ahead and take a look at this next graph. So example 3. I would like you to go ahead and try this out on your own. I'll start with the factoring portion, but we're going to go ahead and then you can, let me just explain it out. So we're going to start off with x minus 1. There's nothing we can simplify there. Okay, but we're going to go ahead and factor the denominator, so that's going to end up being the factors of negative 4 that add up to give me positive 3. And so if I think about 4 and 1, and I need a positive 3, so that's going to be a positive 4 and a negative 1, that would multiply. Okay, notice how the numerator and the denominator both have x minus 1. So with that being said, we're going to end up having our simplified function of 1 divided by x plus 4. Okay, so what we're going to do now is we're going to take a look at this simplified function. And we do have a whole. And that's going to be at x minus 1. Set that equal to 0, and it's x equals positive 1. So we cannot have x equaling positive 1 at all. So let's go ahead and plug that into our ordered pair here to see what the y value would be of that whole. So all I'm going to do here is I'm going to substitute it as f of 1 equals 1 divided by 1 plus 4, which would just be 1/5. So 1 and 1/5 is going to be our whole. And we only have one whole because we only have one binomial that simplifies out of the numerator and the denominator. Okay, and now we're left with 1 divided by x minus or plus 4. So I know on the graph it's going to shift left 4. Now the leading coefficients on this graph is we're going to end up having more in the denominator, so that's going to create our horizontal asymptote. I'm going to go over that more next class, but our horizontal asymptote is going to just end up being y equals 0. All right, so let's go ahead. Do we have an x-intercept? Does it cross the x-axis? No, because of our horizontal asymptote. And then the y-intercept, yes. So if it's a y-intercept, we need to set 0, x equal to 0 to figure out the y-intercept. And we're going to do that with our simplified function. So it's going to end up being 1 divided by 0 plus 4. Okay, we're writing in blue now. Because we know that the x value is going to be 0. The y value is just going to be 1/4. Okay, and then the domain, that's going to end up just being all of the values, but let's go ahead and graph some of these things. So we have a hole at 1 and 1/5. And then our x-intercept, there is none. And we do have a y-intercept, it's going to be 0 and 1/4. So super close there. Okay, and I'm going to pause for one moment. Pause. I noticed there was an error made, and it was this hole that I had graphed. It's really supposed to be 1 and 1/4, 1 and 1, which is over here, and 1/5, so it should be super close. Okay, so as it comes down, here we go. It's going to go ahead and approach and be close to 1/5. Okay, and then on the other side, we're just going to go ahead and kind of sketch what's going on there. And that way it gives us an idea for the domain. The domain is going to be all real numbers, except x cannot equal our holes, which would be +1, or, oh, we forgot to identify the asymptote, which is a vertical asymptote, at x equals -4. And then y equals 0. So x cannot equal 1 or -4. And then our range would end up being all real numbers except y cannot equal 0. All right, so that's it for example 3. Okay, go ahead and pause the video if you need more time with that problem. Okay, and there's only one more example, and this one is kind of comes out crazy, so go ahead and try the best you can based off of the information that you have. I'm going to pause the video. On second thought, for this example, we're going to go ahead and do this one together. So I don't want you to watch the video on this particular problem. You can try it out on your own and see what you ended up with. And then identifying the holes, the x-intercepts, you're just graphing it really. So we will do this one together as a class. So I just want you to pause this video, go ahead and work on your homework, and do the best you can on it. We will be working on it on Friday a little bit, and it'll be due on Monday. As for class, do the best you can. Keep going back and forth between the video and the homework, and today is your day to work on this. Use your time wisely. Thank you. Bye.